Alright, so this is section G from our quadratic chapter of the SL book, and this is the section that you will be missing because of the staff meeting. So we're going to try and do a little bit of explaining and things like that through these videos, and then you can still not miss or not fall behind with the schedule that we're trying to keep. So section G is on quadratic optimization, meaning find the minimum, find the maximum. And what we can do with this is use our completing the square or use this formula. We can find the x value of our maximum by negative b over 2a, or the minimum, minimum in this case, but you see the maximum is the same formula. This is in essence the same idea as completing the square. Completing the square can give you the x and the y. This formula gives you the x. You will then take that x, plug it back in to our equation, and that's how you can get y. With technology, this is even easier, but first we'll go over some that don't. So what we're dealing with is, again, maximums and minimums. Alright, so find the maximum or minimum value of the following quadratic functions and the corresponding value of x. So in this one, let's try and use our negative b over 2a. The b value is 1, so negative b over 2a. A in this case is also 1. So negative 1/2 is equal to our x value. So if we draw our vertex here, negative 1/2, comma, and then we're going to have to plug negative 1/2 in. So negative 1/2 squared would be 1 over 4 minus 1/2 minus 3 equals y. And I don't have a calculator handy, so let's see if we can do this. 1/4 minus 1/2 would be negative 1/4 minus 3, so negative 3.25. And hopefully I did that right, and if not, you can check it later. So this would be a minimum, because we know that our a value up here is positive, which means we have a quadratic like that, which means our vertex is on the bottom, which means it's a minimum. Alright, next we look at this one. Let's try the same thing. Negative b divided by 2a. So in this case, there's a little bit of math here. We have two negatives. They're going to cancel, leaving us with positive 3/4. So over here, 3/4. Take that 3/4 and plug it back in. And this is not going to be that pretty, but let's try it. So 3/4 in for 3x would be 9/4 minus 2 times 3/4 squared would be 9/16. The 2 cancels. Okay, so we have 3 plus 18 over 8. Next time I'm going to bring a calculator with me when I do these. Minus our 9 over 8. 18 minus 9 is, of course, 9. So 3 plus 9 over 8. 3 plus 9 over 8 would be 4.125. Again, good chance I made a mistake somewhere in there. You can check that later. Or you can keep 4 1/8 if you want. But that is how we do this. That's quadratic optimization. Finding the minimums and maximums. Completing the square will also work if you prefer that. Alright, and one more in this section of the video. A story problem. A gardener has 40 meters of fencing to enclose a rectangular garden plot. One side is against a brick wall. Suppose the two new equal sides are x meters long. Show that the area enclosed is given by. Okay, so if this is x, that means this is x up here. And if we have 40, then this is 40 minus the two x's that we already used. So the area equals x, length times width, so x times 40 minus 2x. And that is actually part A. It's just to show where we got that. Pretty simple. What's more difficult is find the dimensions of the garden to maximize area, so we want a maximum. This equation, if we graphed it, would look like that, which means the vertex, is a maximum. That's what we're looking for. So we have negative 2x squared plus 40x, and that's equal to the area, and we want the vertex, we want the maximum. So once again, negative b divided by 2a. In this case, 2 times negative 2, those cancel, and simplify to 10. So the x value is 10, and then you might think, do we need the y? Do we need to find out what the maximum area is? We do not. It doesn't say that, we just need dimensions. So x is 10 by, and we plug in 10 here, 40 minus 2 times 10 is 40 minus 20, that's 20. So 10 by 20 meters should be our answer. And that, again, quadratic optimization, maximization.